Good day, friends. Today's class, we still want to solve more questions on cubic expansivity. We started our topic on heat energy in some of my previous videos. Today, we want to solve more questions on um, cubic expansivity. Let's see the Jamb question at the top. We are told in Jamb 1995, question 19. A rectangular metal block of volume 10 raised to power minus 6 meter cube at 273 Kelvin is heated to 573 Kelvin if its coefficient of linear expansion is 1.2 times 10 raised to power minus 5 per Kelvin. The percentage change of its volume is we have 1.5%, 1.1%, 0.4%, and 0.1%. So let's for cubic expansivity, we have this formula. Cubic expansivity gamma equals to change in volume over original volume and change in temperature. So we are told to calculate the percentage change of its volume, but we have our gamma, which is the cubic expansivity, is 3 alpha, where our alpha is, we are told that if the coefficient of linear expansion is 1.2, so alpha is 1.2, that means 3 times 1.2 times 10 raised to power minus 5, and that will give us 3 times 1.2 is 3.6 times 10 raised to power minus 5. That is for gamma. But we also have change in temperature. Change in temperature is theta 2 minus theta 1. Our theta 2, which is the final temperature, is 573. So we have 573. Our initial temperature is 273. So when we subtract, we have 300 Kelvin. Similarly, so those are the information given in the question. Change in temperature. We are told what is the percentage change of its volume. So we are asked to get change in volume. So we have, if we make change in volume the subject of formula, we have change in volume equals to gamma times V naught and change in theta. So we have change in volume now. Change in volume, we have our gamma is already 3.6 times 10 raised to power minus 5. Our volume, that is the initial volume given in the question, is 10 raised to power minus 6. And we have change in temperature, that's 300. So if we evaluate this very well, we have 10 raised to power minus 6 and 10 raised to power minus 5. That is 10 raised to power minus 11, minus 5 minus 6. So we have 3.6 times 3. 3.6 times 3 times 6, that's 18. Remainder 1. 3 times 3, 9. 9 plus 1, that's 10.8. We have times 10 raised to power 2. This is from 300. So if we do this very well, we have 10.8 times 10 raised to power minus 9. But this is not the answer. Where we are going is that what is the percentage change in volume? So the formula for percentage change in volume, percentage change in volume is our change in volume over original volume times 100. So that's the formula for change in volume. So we have our change in volume, which we have calculated 10.8 times 10 raised to power minus 9. Original volume in the question, 10 raised to power minus 6 times 100. So let's see the result here. 10 raised to power minus 8 times 10 raised to power minus 9 over 10 raised to power minus 6. So if we do this very well, we have 10.8 times applying indices. 10 raised to power minus 9. If you are applying this, division means minus. With this minus coming up, it will change to plus. So the final answer will be 10 raised to 10.8 times 10 raised to power minus 9 plus 3. Minus 9 plus 3, that's minus 3. Minus 9, negative times negative is positive. So let's move 10.8 3 times backwards. 10.8 3 times backward, we have 1, 2. That is 1, 2. Don't forget, we also have times 100. Here now, we have times 100. So before we move it backwards, we have 10 raised to the power minus 3 and 10 raised to the power minus 2. 10 raised to the power 2 will give us minus 3 plus 2. That is 10 raised to the power minus 1. That means we are moving this one once. So the final answer will be 1.08, which is approximately 1.1%. So that is the change in volume from the question given. Percentage change in volume, 1.1%. I hope you have gained something in this video. You can see that this information is very important. There are some students that are bereft of ideas and information. All you can do as parents, as the loved ones, is to share this video to them so that they will go through it before writing the final exam, and they will be very grateful for doing that for them. See you in my next video. Bye.